Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to identify trends in atomic size. So keep your periodic tables handy, and we are going to see what an atom's location can tell us about how large or small it is. The atomic radius of an atom is defined simply as the distance between the center of the nucleus and the edge of the electron cloud. Now, the problem we have is the electron cloud around the atom is not very sharply defined. This is because, as you will remember, electrons are not only particles, but they also act like waves. So we cannot think of atoms as hard spheres like, say, a baseball or a basketball is. So to get to the atomic radius of an atom, scientists actually use bond lengths. Bond lengths are easier to measure. Now, they do tend to give you an atomic radius that is probably a bit smaller than the actual radius, because when atoms bond, their electron clouds will intermix a little bit. However, it still gives us a basis to compare all atoms. So for example, we might take the fluorine molecule, which is a diatomic molecule, F2, and we will measure the bond length, which is from nucleus to nucleus. Then the atomic radius of fluorine is simply half of that length. We can also do this with metallic bonding. So let's say we have a sample of calcium metal here. Again, we can measure bond lengths from nucleus to nucleus, and then the radius of the calcium atom is simply 1/2 of whatever the bond length is. We can also use bond length for two different atoms. Let's say we have chlorine bonded to sodium. As long as we know one atomic radius, we can find the other. So if we know chlorine's atomic radius, we can then simply calculate the radius of sodium. Now let's define the trend in atomic radius. As we move down the periodic table, atomic radius increases. As you move across from left to right, atomic radius decreases. We see an increase in atomic radius as we move down a group because we are adding, of course, a whole new shell to the atom. So our value of n, our principal quantum number, is increasing. Now, as we add a new shell, we are also increasing the number of core electrons. The core electrons create a shielding effect for the valence electrons. So the valence electrons experience less of an attraction from the positively charged nucleus. Therefore, the more shielding the valence electrons experience, the less they are pulled into the nucleus. More core electrons mean more shielding. What about the fact that atomic radius decreases moving from left to right? This is a little less intuitive because we are adding protons and electrons to atoms. However, the electrons that are added are in the same shell, moving from left to right. However, as we move across, we are not adding any more shielding for the valence electrons. This means they feel the pull of the positively charged nucleus, and the atom actually shrinks a little. So fluorine is actually a little bit smaller than oxygen, even though we have added a proton and we have added an electron. It is easy to assume that adding electrons would automatically make atoms larger. But now we see how other factors like shielding play an important role. Atoms are not always as simplistic as we think they are. I hope you found this video helpful, and thanks so much for watching.